Welcome to Problem Solving with Miss Jones. I chose a problem like this because there are a lot of moving pieces. This is the diagram just with the stuff that's given. I already went ahead and converted all of the centimeters into meters, so 0.93 and 0.30. I also went ahead and converted the 40 grams into kilograms, so make sure that you don't forget to convert. So the goal here is to find the distance that it goes off the table. So here's what's happening. The mouse is going to accelerate the piece of cheese from rest to a final velocity here at the end of the table. And that final velocity will be the initial velocity that it leaves the table, and we're going to have to do a projectile motion problem. So the first step is to use F equals ma to find the acceleration. So there's only one force in the horizontal direction, and it's the force from the mouse. I forgot that in the original diagram. So we have 0.5 equals 0.04 times acceleration. So we get an acceleration of 12.5 meters per second squared. So the mouse is going to accelerate it over this little distance here, and we want to know how fast it's going when it leaves the table. We know that it's going a distance of 0.30 meters. Its acceleration is 12.5 meters per second. And we know the initial velocity is 0. So that's three things. That's enough. I want to find the final velocity. So when you look at your constant acceleration equations, we want to pick the one without a t in it. So I picked the one with the vf squared equals vi squared, substituting in, and when you solve that for velocity final, you get 2.74 meters per second. So that's the speed that it exits the table. So the final step here is going to be a projectile motion equation, and for that we make a chart. So for projectiles, we make an XY chart. I'm going to fill in everything we know. The ultimate goal is to find X, so that's what you want. This velocity down here that we just got is going to be the X velocity. No need to break them up because it's going to be straight off of the side. So there's going to be no initial velocity in the Y direction. In fact, I'll go ahead and write that in. Velocity initial in the Y is 0 because it's going straight off the table horizontally. This is going to be 2.74. We don't know time. We know the acceleration in the X is always 0 because there's no forces. Once it's flying through the air, there's only gravity, which gives you an acceleration in the Y direction of negative 9.8 meters per second squared. We also know that it's going to travel downward 0.93 meters. So X will be negative 0.93 meters. All right, so we don't have enough information in the X to find our distance here. So what you need to do is solve for time in the Y direction because the time is going to be the same for both. So when we do this, I have all these givens here. I want to pick the one that doesn't have velocity final in it. So here's our equation that doesn't have velocity final in it. It's nice that the initial velocity is 0, so that goes away. So this isn't too hard to solve. Your negatives are going to cancel out. Don't forget to take the square root of that. And when you do that, you get 0.436 seconds. And now we're going to use that in the X direction. And again, we don't have a velocity final, so we want to use the same equation. So we're going to use the same equation here. Again, it's nice that our acceleration is 0. You probably already know that. You don't need to. Just have to multiply these two together, and you get X equals 1.19 meters horizontally.